Hello everyone, welcome to Reactive Labs. Today we will talk about another structural design pattern called composite design pattern. So it is composite, not D, just composite pattern. Okay, so let's start with omitting this backspace. Okay, so let's start with the technical definition. What is composite design pattern? Composite pattern is a structural design pattern that lets us compose objects into tree structures and then work with these structures as if they were individual objects. Okay. So basically, wherever a tree like structure is getting formed, there we have to see that composite pattern is used. For example, the most common example is office. So it goes like this, right? CEO. CEO has, let's say, under him VP, VP. Multiple VPs will be there, obviously, but I'm going with one only. CEO has VP. VP has, let's say, director. Director has manager, and manager has you. Okay. Similarly, there will be multiple VPs within a CEO. Each VP will have multiple directors. Each director will have multiple managers, and each manager will have multiple individual contributors, out of which you are, let's assume you are one of the individual contributors. So if you see, these designations may be different, but one thing that is common among all of them is they are all employees of the company, right? And there is one fundamental difference between you and these people, your manager, director, VP, and CEO. One fundamental difference is that you don't manage anyone. Okay. But other people's, um, actually these are all managers. So director is manager's manager, VP is director's manager, CEO is VP's manager. So others are managers, right? So this is the difference. So we have to account for that, and that's it. So basically there is a tree like structure. If you see, this is the root of the tree, then it has multiple nodes, then it has multiple nodes, then it has multiple nodes, and you, the individual contributors, are the nodes which are basically the leaf nodes. Because for a tree, we need leaf nodes, otherwise, the traversal will never stop. So, this kind of structure is getting formed, right? Another very common example is the file system example. So, if you see, there is a folder. Inside that folder, there can be multiple folders, folder 1, folder 2. Actually, let's use the term directory. So there will be a directory. It will have multiple directories, right? Or it can also have files. And each directory will have either a file or a directory. It can have only directories as well, or it can have only files as well, but the file will have nothing. So basically, if you see, this also acts like that. The file is the individual contributor who does not manage anyone, but directory manages these, manages other managers or the individual contributors, right? So this is it. This is where the composite pattern comes into picture, when you have to form a tree like structure with objects of similar type. Okay, so let's start with code, and that fundamental difference that I told you about will be taken care of, and I'll show you how. So basically, what is that? We have a file system component, right? So let's name it file system component. So we have an interface. This is an interface, and it will have two classes. One will be a file class. Sorry, one will be a file class, and another one will be a directory class, right? So if you see, let's name it class. If you see, the file will have two things. One will be the file constructor to create the file, and there will be another function called show. Show means to show the contents of the file. Okay. Similarly, this directory will also have a few things. One will be a directory constructor, right? One will be show, obviously. One will be show. But directory can have files as well. Files or directories means we can have a functionality here called add, and it will take an object of file system component. And this file system component object can be either a directory or a file, right? File system component, let's say fs. Depending on the file or directory, we can call this add and it will add the directory or file to it. And if we can add it, we can also remove it, right? So we'll use the same thing, file system component, while removing it as well. File system component fs. So it's nothing, everything is more or less the same. Yes, one more thing which will be there in the directory, if you see. So directory has to maintain a list, because when we add, we have to show that it exists, right? So we will have a list of file system component, and let's name it list. Okay. So when you add something, you will just add it. When add is called, it will add to this list. When remove is called, it will be removed from this list. Okay. Everything looks perfect here. The only one thing which will differ here is the show will show the contents of the file, but this show will show the contents of the directory. And if we have a directory like this, let's say the directory is there, and it has directory and files, and it has directory, and it has file. When show is called on this directory, it will go and call the show on this directory as well. And when this directory show is called, it will recursively call this directory. Similarly, this directory calls this, and it will call the file. This will call the file. It will, the show will display the contents of everything, all the components of all the objects which are below that directory in the tree hierarchy. So everything will be called, right? So basically we have to take care of the recursive thing here. So basically this show, if you see this file, for the file, the show will only print the contents, right? Print the contents. But what will this show do? This show will do, let's see this. So this will iterate on that list. So for items in the list, which list? This list. For items in the list, what it will do is it will call show, basically items dot show. And once this show is called, if this item is a file, it will print the contents. But if this item is a directory, again this recursively, this items will be iterated on the list which is there inside that directory, right? I hope this is clear. Just one thing, I'll show you how client is going to use it. So let's see, there is a client and we have a file. Let's say we have a file 1. The file was created using the file constructor. We have a file 2. Okay. We have a directory 1. Okay. We used, let's say, the add functionality and added file 1 to directory 1. Okay. So this directory 1 now has file 1, right? And let's say we have one more thing called directory 2. I'm using this example just to show it how this works. And let's say what we did was we called directory 2 to add file 2, and also we called directory 2 and add function on directory 2 to add directory 1. So when directory 1 is added to directory 2, it will be like directory 2 already has file 2 and it will be added with directory 1. And when directory 1 comes, since directory 1 has file 1, this will also come with it. And now when we call the show function on file 1, it will only print the contents of file 1, right? When we call the show on file 2, it will print the contents of file 2. Now, when we call the show on directory 1, what it will do is, it will not print actually. It will call the show on directory 1 and whatever the contents it has, since it has only file 1, so this will print the contents of file 1. But now if we call show on directory 2, what this will do is, first it will come here in this level, it will see there is a file, so it will print the contents of file 2. Now it will see that okay, now there is a directory has nothing, directory just calls the print function, show function again, right? If you see here, if it is a file, it will show this. If it is a directory, it will call the show again, this show will be called again. So in this directory the show will be called again, and it will see that okay, it has a list of files which has this file, then now this will print file 1. So calling directory 2 will print these. It is not printing the contents of directory 1 and directory 2 because directories have nothing actually. Directories have only files which have components, which has contents, right? The directories are just used for holding that. So unless there is a file, it will not print. Or let's say if we would have added something like here, instead of this, if we would have added print directory, then this would have been printed here. So in the case of directory 1, along with print file 1, there is one more thing which would have printed, is print directory 1. Similarly, for directory 2, first of all, print directory 2 was printed, then print file 2, then print directory 1. Okay, from here it will go here, and from directory 1 it will print file 1, right? So I think this made it clear, the composite design pattern. Similar thing will go with the manager and employee. If you have to see, for example, I'll just quickly show the example. For example, let's say you use a function called show salary and you put in CEO. So what happens is, you will see the CEO's salary, then you will see the VP salary. So actually you have to show, basically you have to check the salary starting from CEO level to everyone. So you just give the CEO object, and from here till all the individual contributors salary will be printed. Okay. But if you want to see the salary of only individual contributor does not manage anyone. So only this person's salary will be printed, right? So this is how it works. Another thing is, if you want to know what is the hierarchy like, so you just, if you have to know from which level, you have to know from director level, let's say. So you just give this director level as the object in show levels. So you put director, everyone inside the director, starting from the root as director to the individual contributor level, everyone will be printed. Similarly, if you use show levels on CEO, again starting from CEO, every employee in the company's data will be printed. So that's it. I've tried to explain this composite pattern in the most understandable, easy way possible. I hope this helps. So thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.